In this video, we continue our discussion about tests of significance, and our learning objective is to conduct a test of significance. So let's just go back to the Tootsie Roll example that we were talking about in a previous video. This time we have actual data. I sat down, ate 6 Tootsie Roll Pops for you, counted my number of licks before I reached the center. And so here's the data. The mean of this data is x bar is equal to 35.17 licks, and we assume that the standard deviation is 32, because remember, we don't actually have this information. So because I collected this data myself, I had to create a standard deviation that makes things work out nicely. All right, so recall that our claim, H0, our null hypothesis, is that mu is equal to 3, and HA, mu, is greater than 3. We made these claims before the experiment, okay? So what we do is we assume that the null hypothesis is true. We assume that mu is actually equal to 3. So this implies that the sampling distribution of x bar for n equals 6, so we only have one sample, but we have to assume that all samples for the sampling distribution is n equals 6, is, according to central limit theorem, normal, where mu is equal to 3, and the standard deviation is equal to 32 over square root of 6. Okay, so a few things to note. We're always assuming that H0 is true at the beginning of this test of significance. Okay, and what we're doing is we're attempting to show it's false. Right, so we do this by looking at the sampling distribution where mu is equal to mu 0. So examine the sampling distribution where mu is equal to mu 0, and in our case that's 3, and then the standard deviation is sigma over square root of n. Okay, so we're given that x bar is 35.17. Remember, on this x-axis, these values represent the x bars. Okay, so this is 3, and 35.17 is here. All right, so notice how far away 35 is from 3. Moreover, notice how tiny this area to the right is. So what a test of significance does is it will examine the proportion under the curve in the direction supported by our alternative. So in this case, greater than. We examine this area. If the area is super tiny, implying that evidence is far away from this mu, then this is evidence against H0. Keeping that in mind, and also keeping in mind that we've already stated H0 and HA, now we can conduct the test of significance in parts. So the first part is the z-test statistic. Alright, so this is called a z-statistic, but it is just a z-score. Okay, so recall that the z-score is calculated x minus mu over sigma, but because we're on the sampling distribution, x is actually x bar, mu is mu 0 because we're on the null sampling distribution, divided by sigma is not just sigma on the sampling distribution, it's sigma over radical n. Okay, so we're just substituting for new symbols that represent similar things. Okay, and this z-statistic measures how far the data from our sample diverges from what we would expect if H0 is true. That's a lot of words. I'm going to write them down. So this z measures how far the data, meaning x bar, which is a summary of the sample, from our sample, how far the data, summary, from our sample diverges from what we would expect if H0 were true. Which is why, so if H0 were true, this part comes into play when we're talking about mu0 and that standard deviation, okay? So the further away x bar is from mu0, the larger our z statistic will be. You should probably summarize what this means in your own words, okay? If what you say doesn't make sense, then that means you should probably bring that into class for questions. All right, a second thing that we have to calculate is something called a p-value. If you've worked in science before, science research, then you know what the p-value is, but maybe you didn't exactly cover what it means theoretically. So the p-value is the probability that, again, we're assuming H0 is true, so the p-value is the probability that a value is at least as extreme as the test statistic would be observed under the null hypothesis. The smaller the p-value, the stronger evidence against H0. What? Alright, so in our example with the Tootsie Roll Pop, the p-value is just that probability or the area under the curve that I was talking about. Here's 3, here's that 35.17, and this area to the right. So this is the probability that a randomly selected Tootsie Roll Pop takes over 35 or equal to 35.17 licks, okay? So area under the curve, remember, represents, because this is a continuous probability model, it represents the probability, and x represents a randomly selected Tootsie Roll Pop. Okay, and because this area under the curve is associated with values 35 or greater, we could say that the area under the curve is the probability that a randomly selected Tootsie Roll Pop is greater than or takes more than or equal to 35.17 licks. All right, and so this is saying the p-value is the probability that a value is at least as extreme as the test statistic would be observed under the null hypothesis. So this is the null distribution. This is the probability that a value, so x, is at least as extreme as this value you observed. When we're talking about the test statistic, we are talking about z, but z is just a transformed x bar, if we remember what that formula is, right? We're just transforming x bar to be in the standard normal curve. If you don't remember what I'm talking about, you should go back and review chapter 3. Right? Now, if we had gotten an x bar that was down here, which is weird because that's just 3, so I guess physically that can just be 1. This is the same meaning. This is the p-value, right? At least as extreme as is a weird way to say greater than equal to as well as less than equal to. Okay? It's either this or both if we're talking about two-sided hypothesis. And here we see it written more formally. So if we're dealing with an alternative hypothesis involving a greater than equal to sign, then we're calculating the probability or area to the right of the score. These should actually be capital Z's. I apologize for that. Capital Z, capital Z, capital Z, where lowercase z represents a value, sort of like this. Okay. And then if it's two-sided, then you would just choose one of these and multiply by 2. To lay out the steps for a test of significance, so you can practice. 1. State the null. 2. State the alternative. 3. Once you have that, calculate your z-statistic. 4. Once you have your z-statistic, find your p-value. And last will be to conclude using significance levels. We haven't covered that. That's going to be covered in the next video, using significance levels.
My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. We live in a world of technology. They're collecting information on your humanity. Social networks, gaming, and in-home software.
Hello, Alexa.
Statistics helps us be more aware. Haters gonna hate my spicy lyrics. Why you gotta be so mean? Pulling me towards your extreme moods, but the median never fails to center me. 50 to my left, 50 to my right. Got these correlation and regression tools, forget them fools. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. The mean of the means is the mean. The mean of the means is the mean. The mean of the means is the mean is the mean of the means is the mean is the mean. Be careful not to fall in love. Statistical seduction from above. Your shape so beautifully symmetric to the eye with a single peak so high. I hypothesize and can testify that your p-value is the smallest I've seen. Mix that with a large power and I reach ecstasy. Your residuals defy the rest. A small scale randomized pattern tells me you are the best fit. My name is Llama, and I'm here to teach you stats, skilling you up with the cold hard facts. My confidence is so high, 95%. My margin of error so narrow, 110. Can you feel me? Can you feel me? I estimate your population parameter based on only one sampling. Oh, haven't the frequentists told you about me? We live in a world of data, attempting to understand life by statistical strife. The implicit bias of cops, success rate of them jocks, medical advances, and AI romances. Statistics.